Hi everyone, we're going to use mathematical induction to prove the property for all positive integers n, and we're going to prove that 2 is a factor of n to the fourth minus n plus 4. And we're going to start with condition 1 of the principle of mathematical induction and show that it works for n equals 1. So I'm going to take this and plug in 1. And this equals 4, and 2 does divide 4, thus 2 is a factor of 4. And then we're going to show for condition 2 for n equals k. So we're going to write this as k to the fourth minus k plus 4. And we're going to assume that 2 is a factor. So assume 2 is a factor of this. Because we're going to have to assume that. Now we're going to check for k plus 1. And everywhere there's a k, I'm going to put k plus 1. Now on this one, I'm just going to use my binomial theorem, or you can use Pascal's triangle. Remember on Pascal's triangle, when you have anything to the fourth, you're going to have 1, 4, 6, 4, 1. So this is going to be k to the fourth plus 4k cubed plus 6k squared plus 4k plus 1. Alright, and then we're going to distribute the negative here. You get minus k, minus 1, and plus 4. And I'm going to use the other slide, but what I want to do is, since I've assumed that 2 is a factor of this right here, I want to pull out k to the fourth. I want to pull out negative k, and I want to pull out plus 4. So when I do that, I'm going to go to the next slide, and then I'm going to clean this up. If I clean this part up, you'll notice that the ones will cancel out, so we'll just be left with this part. So I'm going to do grouping a little bit. So I'm going to have k to the fourth minus k plus 4, which we already assumed is divisible by 2, and then I'm also left with 4k cubed plus 6k squared plus 4k. Now, I could factor out a 4k here. We already know that this is divisible by 2, and what I'm going to do here is, on this side, factor out just the 2, because that's all we need, and this is going to be 2k cubed plus 3k squared plus 2k. Since this is also divisible by 2, because you can divide this by 2, this whole thing is divisible by 2, we can assume that 2 is a factor of the entire expression, because it divides both pieces. So it's a factor of the sum of these two. Therefore, 2 is a factor of n to the fourth minus n plus 4 for all positive integers n. Alright, thank you. Have a nice day. Bye-bye.